Okay, let's get started. Hello, everyone. Welcome to Introducing Purdue Engineering, our 2021 edition. My name is Ari Swartz. I'm the Assistant Director of the Office of Future Engineers. I'm so glad to have you joining us. We've got a great program for you tonight. We're going to start off with a brief overview of engineering in general as a field, going through the different majors in engineering we have here at Purdue. Going to give you a little pre-recorded tour I did of some of our engineering facilities and our engineering part of campus. And then we're going to open up to a student panel. I've got three fantastic current engineering students lined up to share their experiences, talk about why they picked Purdue, and answer some of your questions at the end. So as we go throughout this, feel free to send in some questions through the chat here in YouTube. We'll have that open Q&A at the very end of the program, but don't hesitate to start sending some questions now if they come to mind, and we'll get to them at the end. So with all that in mind, we've got a lot to go through in just about an hour, hour and a half. So let's go ahead and get started with our presentation here. I just want to check, make sure, can everyone hear me? Things look good on my end, so I think so. Just want to make sure I don't get deep into a presentation and then end it and realize that nobody can hear me. So I think everyone can hear me. Yes, awesome. I see it in the chat. Great. Well, let's get started then. Now that we know you can hear me. So a little bit about me, so you know who's going to be talking for the next 45 minutes or so. I am the Assistant Director of the Office of Future Engineers. Basically, I oversee a lot of our online programs. I oversee our communications and marketing efforts for the Office of Future Engineers. The Office of Future Engineers as a whole is the outreach arm of the undergraduate engineering programs here at Purdue. So we're your kind of go-to resource for anything you want to know about the undergraduate engineering programs here at Purdue. I'm originally from a small town in Oklahoma. I've been at Purdue though. I went to Purdue as a student and started working for them not long after I graduated. So I have been here at Purdue for, let's see, going on, well, I haven't done this math in a minute. Wow, has it really been almost 13 years? Almost 13 years. Pretty crazy. When I was a student at Purdue, I was involved very heavily in Purdue bands and orchestras, marching band, concert band, orchestra, you name it. I was a part of it. I was also a resident assistant in the on-campus housing, overseeing one of the floors and one of the residence halls. I had a variety of campus jobs, did a lot of student leadership activities. So I really had a wide range of experiences as a student here. And then when my student panel joins us later on, I'll have them talk about some of their campus involvement as well. And hopefully a lot between the four of us, you know, whatever it is you're interested in, hopefully we might be able to represent it on our panel later on. Okay, so let's get the actual presentation out, the introductions out of the way. What is engineering? So whenever you think of the field of engineering, what comes to mind? Some people think of those locomotives, the people that drive the trains. Those are called engineers. Well, we do a different type of engineering here at Purdue. Maybe you think of cars or motors or rockets, that sort of thing. But if you were to try to boil it down to a definition, can you think of one off the top of your head? What is a good, like short, maybe one sentence of what is engineering? Kind of hard, right? Engineering is a very broad field. So how could you possibly condense that down into one sentence? Well, I've tried. Kind of when you really look at engineering in a nutshell, engineering takes what we've learned about the scientific world and we apply those discoveries to solve real-world challenges. So we're kind of the next step after the scientific world. Once we've learned the things, we're going to try to implement them and find a way to implement them. So when you look at the timeline or the spectrum of science, engineering, and technology, or engineering technology at Purdue, we're in the middle of this spectrum. So science discovers. They are learning more about the world around us, how it works, and that sort of a thing. Engineering then implements, and then when you look at engineering technology programs or just other technology programs, which are housed in the Polytechnic Institute here at Purdue, they improve upon these technologies that have been developed by scientists, engineers, and find other uses for them. So I've got a specific example in these three photos here on this slide, which it looks like it's not showing. Sorry, hang on. Not sure why it's not following along. Sorry, everyone. Still nothing. Oh man, you guys. So is anybody seeing, are you just still seeing, yeah, you're still just seeing the Introducing Purdue Engineering. Oh gosh. Give me 1 second. Let me see if I can sort this out for y'all. Okay, I'm going to do this a different way. So now you can see. So I don't want to take us back to all the way back to what is engineering. We've kind of covered that. I saw we had a lot of great answers that were coming through. So going back to our definition, engineering takes what we've learned about the scientific world and applies those discoveries to solve real-world challenges. So going back to, I mentioned I've got science, then engineering technology. So in these 3 photos you see here on the screen, I've kind of come up with a specific example. This is really like an oversimplified definition of the difference between, but just as a little example. So on that far left above science, that is silicon carbide. It's electroluminescent. Scientists discovered that many, many years ago, that it's electroluminescent. If you put electricity through it, it's going to glow on its own. And the research kind of stopped there. They were like, here are some potential applications for this, but then they wanted to go on to the next thing. They wanted to find the next thing, the next breakthrough in science. So then many years later, an engineer came along, who was actually a professor at Purdue for a little bit, and he wanted to see if he could find a useful application for silicon carbide. What could we use that for? And he actually invented the LED light. It actually used silicon carbide as that light source in an LED diode. The first LEDs were infrared, and they were actually used in remotes to control TVs. So you don't have to go up and change the dial anymore. And then, again, many years down the road, engineering technologists can come along, and they can look at this, hey, these are cool. Are there more applications for LEDs than just remote controls? Can we do more colors than just infrared spectrum? So they can kind of take that concept, that new technology, and innovate with it, pioneer it, find other uses. So we can use them in taillights for our cars. They last a lot longer than your traditional bulbs. They use a lot less electricity. And as we're getting more computer systems, electrical systems in the cars, we need to be very energy efficient for the batteries in them. So lower power, longer life, lower cost. So that's, again, a very oversimplified, but a pretty good example of how each field has a lot to bring to the table and is very critical to the world around us. But they're each a little different. There's always going to be a little gray area, especially when it comes to careers as far as an engineering degree versus engineering technology degree. But generally, this is kind of how they all work together out in the real world. So what makes a good engineer? I saw somebody mention creativity. That was a really great response. That's something that I think is really often overlooked for key traits and skills that make a good engineer. Now, I'm not saying you have to have all of these and be super proficient and all of these things, name you to a T, but these are just some of the key traits and skills that would make for a really good engineer. Some of them are going to be very obvious, what you might think of. Others might not be so obvious. So obviously being very analytical, very detail-oriented, that's going to be very critical. Being very communicative. So engineering has this stigma that it's a bunch of nerds that aren't adjusted socially, which is completely untrue. Engineering is actually very much a team sport kind of profession. You're going to almost always be working in teams, both in the classroom, and I'll get to that later on, but also out in industry. You're going to work with teams of engineers and management people to help solve these challenges. So you have to be very communicative in expressing your thoughts and ideas in a well-fashioned way. Being very inquisitive. So engineers, we are trying to solve problems that have not been able to be solved before. So having that inquisitive nature to look at things and maybe look at it from a different perspective. How does that work? what makes it tick? Did you maybe take toys apart when you were a child? Being very creative, as I mentioned. So this is another very key skill, because it may seem weird being very analytical and detailed, but also being very creative. But since we're trying to solve things and create things that haven't been made before, you have to have that creativity to see things in a new light and kind of create things that haven't existed and kind of expand on your own creative mind. Being very logical, again, they can play together, being logical and creative. Having an aptitude for math and science. Now, I use the word aptitude very specifically. I didn't say a love for math and science. I didn't say a mastery of math and science. You have to have an aptitude for it. Just be able to understand it, do it. You don't have to love it. I know a lot of people really don't like their math classes. They find them very tough. The good news is for engineering, that's a small part of the field of engineering. Yes, you are going to take math and science courses. That's why you have to have that aptitude and just be able to do it. But you're not going to live and breathe formulas and numbers and those sorts of things as an engineer. They're just key skills that you'll need to get on down the road. Being a problem solver, being very collaborative, that kind of goes back to the communicative, being collaborative, working in those teams, and then having a technical aptitude as well. So understanding, the tiny little amounts of things, the nuances of things in complex systems. So again, you don't have to have all of these. If you weren't the one that kind of took apart your toys as a kid, that's okay. You don't have to freak out. But these are some of the things that go into being a good engineer, because we are solving these complex challenges and working with complex technologies and concepts and ideas. So that, again, is kind of just describing kind of what an engineer is, or like some of the features of an engineer. But what does an engineer actually do? What are some of the actual tangible things that they do? So this is where I'm going to take you on a brief tour of all 17 different engineering majors here at Purdue, with a couple real-world examples of each. Again, that's a lot of things to try to go through, so it's going to be very kind of superficial for all these different majors, but the idea is this will kind of get your feet wet, a little introduction to the different majors, and then hopefully spur some interest on your side to figure out, oh, that actually sounded really good. I'm going to start looking into that down the road. So here we go with a very brief and very quick overview of the engineering majors at Purdue, starting off with aeronautics and astronautics. This is a single major, so it's in the School of Aeronautics and Astronautics. So you can specialize sort of more towards the aeronautical side or more towards the astronautical side, but your degree is going to be a Bachelor of Science in Aeronautical and Astronautical Engineering. So with Aero-Astro, you have several different kind of research areas, focus areas there underneath the pictures: aerodynamics, aerospace systems, astrodynamics in space, propulsion, structures and materials, what all these ships and aircrafts are made out of. And then these two pictures are a couple student examples. So on the left there, that's one of the aero engineering classes. It's AAE 418. It's the Zero Gravity Flight Experiment class. A team of AAE students was selected by NASA back in 2019. We actually have had students selected almost every year for the last several years. They were selected by NASA for a micro-G neutral buoyancy experiment design team. It's NEXT for short. They got to go to the Neutral Buoyancy Lab in Houston. It's this giant pool where they're able to simulate microgravity at the base of this very giant and very deep pool. They actually have a mock-up of parts of the International Space Station down there, and astronauts can train down there in their spacesuits before they go out to space. So anyway, a team of students was designed to take a project to this Neutral Buoyancy Lab to test out a tool that they designed and built here at Purdue. It's a tool that was designed and built on campus specifically for a spacewalk camera. So the idea is they've got the spacewalk camera that they have. It's a little clunky to work with, so they've developed this mount for it that can mount to the side of the ISS on the handrails. So they've developed this mount that's supposed to attach to an already existing camera. So they got to take it out to Neutral Buoyancy Lab, hook it up to the camera, and hook it up to that mock-up of the ISS down at the bottom of this pool to see how does it actually work in practice in this simulated microgravity environment. Very, very cool. The picture on the right, that's actually started out as a student organization and turned into an actual startup company. So it was a team of aeronautical, mechanical, and industrial engineering students that had this rocket, Raccoon really was what it was, club. So it uses high altitude weather balloons to send a payload, a small rocket, up into the high altitude atmosphere, and then a small rocket that can take it into low Earth orbit. So it's a lot more energy efficient. You don't have to propel it all the way from the ground by that rocket. They've actually turned it into a company called Leo Aerospace Incorporated. So Leo for tiger, or lion rather, but also for low Earth orbit, Leo. They are reusable high-altitude balloons. They take rockets and cargo up to about 11 miles up into the air, so there's 95% less atmosphere up there, so that means there's less drag and less fuel required to then propel it with that rocket up into low Earth orbit. So really cool how it started out just as a club, and then utilizing, we have some fantastic resources on campus for startup incubation and learning how to run a business, start a business. They use those resources to actually get their feet on the ground and start a company based out in California, which is very cool. Next up, agricultural and biological engineering. There's actually 3 different degrees within this division of agricultural and biological engineering. ABE for short. It's a very unique program in general in that it's housed concurrently in the College of Engineering and the College of Agriculture. So you're technically a student in both of those academic colleges here at Purdue, which also means you have access to resources from both of those colleges, including scholarships, which is cool. So you can do agricultural engineering, you can do biological engineering, or you can do environmental and natural resources engineering. So a few different pathways there. Again, you can see the research areas there at the bottom: agricultural safety and health, agricultural systems, which is essentially looking at farming practices and technologies, fluid power, so how do we make these large pieces of machinery, these large combines and tractors to meet the needs that we have for these large farms, machine systems, that goes along with the fluid power, environmental and natural resources, which is looking at sustainability and our ecological environment around us, and how can we make sure that it's going to be protected and that things that we're doing are sustainable and efficient. And then on the biological side, that's that second row down here. So that's cellular and biomolecular. It took me a long time to be able to say those words without messing them up. Cellular and biomolecular, food and biological process, pharmaceutical process, bioprocess, bioenergy. So basically, the biological side, you're looking at the cellular level of things to create, you can create food and biological agents that are used for good. So one of our students was working with benzene, or was creating a bacteria that could target benzene that's found in the lungs of smokers to break down that benzene chemical into its base components and kind of neutralize that carcinogenic risk of benzene in the lungs. They can build pharmaceuticals, so the base ingredients to turn into the pharmaceutical process, and things like biofuels and biomaterials. That all falls into biological engineering. So the picture on the left is actually from the agricultural, the machine system side. That's part of the AgBot Challenge. It's an annual competition where it's autonomous farm vehicles that do a specific purpose. So that year, it was called the Weed and Feed competition. So an autonomous vehicle had to find and scan rows of corn out on this test field and determine its health. And they also had to find weeds and eradicate them by either spraying them or digging them up. And all of this done autonomously. So the person you see there on the cart is actually just there just to monitor things. It isn't actually driving or doing anything. So you want to talk about some really cutting edge autonomous vehicle design, you could actually really get that in the agricultural engineering program, which is really cool. There on the right, Jake, who is a senior in agricultural and biological engineering, was actually a health and safety officer for Boilers to Mars. It was a Purdue team that's going to a Mars desert research station in Utah, obviously not on actual Mars. And it was a two-week mission to simulate living on Mars and conduct tests. And Jake's job as a biological engineer was actually researching microbes found in the astronauts' living quarters on this simulated station. So trying to determine if there's what was there, and if any of them could develop into a pathogenic strain that could cause illness. So he graduated a while ago, but is finishing up some of the research with one of the ag and bio professors, looking into how some of those microbes can actually play a role in IBS too. So kind of separate from Mars, but what he had learned from this experience, looking at microbes and how they might impact or even help those with inflammatory bowel disease. So some pretty cool examples of agricultural and biological engineering there, very wide ranging applications. You might think when you hear of agricultural engineering, you might just think of farms. It is far more than that. It's autonomous vehicle designs, robotics, UAVs, drones, pharmaceuticals, biomaterials, and biofuels. It really spans a wide range. Next up is our biomedical engineering program. Biomedical engineers are going to basically exist within the healthcare industry, or at least framework. So they're looking at biomaterials and structures that can be prosthetics that are added on to replace mobility that might have been lost. Instrumentation, so looking at medical imaging devices and just better understanding what's going on in the human body. So X-ray machines, CT scanners, those sorts of things fall underneath biomedical engineering. Imaging devices, neuroengineering, so understanding how the brain works is a key part of biomedical as well. So as we develop these instrumentation and imaging devices to scan the brain, how can we tap into its functions and restore brain function that we might have lost, or attach that prosthetic arm we have? How can we actually get it to interface with the brain and move this prosthetic arm just by thinking about it instead of having manual controls or that sort of thing? And then healthcare systems engineering, essentially looking at a hospital or a healthcare system as a whole, trying to innovate and make it more efficient, make sure we can treat more patients more efficiently and effectively, and really just try to keep things going smoothly in the system as a whole. So on the left, this was a team that created what they called HANA, the Heart Attack Notification Agent. It was a senior design project, and it was a device that could be worn at home and can detect a heart attack and notify the wearer, which may sound silly. That's like, well, wouldn't you know you're having a heart attack? Actually, maybe not. So roughly half of heart attacks in the US occur outside of a hospital, and 88% or so of those end up being fatal. And especially in women, the symptoms of a heart attack can be quite mild, and the person may not even know that they're having a heart attack. So this is where this HANA device can come in. It would actually notice that in your biometrics and send an alert to the wearer and to an emergency contact, so that help can be sent immediately. Every minute is critical during a heart attack. And on the right, this is a low-cost auto CPR device that was developed by 4 biomedical engineering students a few years ago. Actually won the Engineering World Health Competition when they were doing this. It can repeatedly apply around 154 pounds of force to a CPR patient's chest, which basically duplicates the CPR process. So if you're in a pinch, nobody knows how to do CPR, you can grab this thing and strap it on. It sounds scary, but it works really well. It's powered by a 12-volt battery using very cheap materials and very readily available materials. And so the final manufacturing cost was just under $600, which compared to existing products that are currently on the market that cost over $10,000, it's a really great low-cost alternative, especially for developing countries and organizations that may not have the funding, to buy a piece of equipment that costs tens of thousands of dollars. Next up is chemical engineering. So that's another very wide-ranging field. Really, all of our fields of engineering have wide-ranging applications. But for chemical engineering, it's biotechnology, fluid mechanics, nanoscale engineering, polymers and materials, solar energy. So essentially looking at the chemical composition of the world around us and figuring out how can we use that to our advantage or how to remediate something. So as a couple of examples here, on the left, that's from our solar cell research lab on campus. We can actually develop and build solar cells from scratch using innovative methods and compounds. So we're trying different ingredients, essentially, different production methods to see if we can make solar panels more efficient. Right now, our most efficient solar panels are only around 22% efficient. So that means we're losing over 70% of energy that we could be capturing. So we're trying to find ways to boost that, to make it more efficient and therefore better energy density, those sorts of things. And then on the right, this is looking at kind of the other end of the spectrum. So solar power is generating power. Then on the right, we're looking at storing power. So that is carbon nanofibers and a potassium ion battery. So the battery that's in your smartphone is probably lithium ion. We've also had the alkaline acid batteries, those sorts of things. Potassium ion is supposed to be kind of an alternative. So potassium is far more plentiful and cheaper than lithium across the globe. It's also, with it being more plentiful, it's much cheaper. So it's not quite as energy dense as lithium ion, so it probably wouldn't replace the lithium ion batteries in your phone, but it can be a real game changer for solar electric grids, power grids. So one of the issues with solar power and wind power is, they generate when they generate during the day or when it's windy. There's not much we can do if there's peak demand when there's no sun or no wind. So if we can capture some of that energy during those peak production times to store that for peak demand times, that would be a game changer. The issue right now is having that size of battery applications for power grids is extremely expensive. Potassium ion can offer a much lower cost alternative for that, so we might be able to store that energy on a much larger scale, on a much cheaper way. So chemical engineering, that's a couple examples. They also have a large part in food and pharmaceutical production. A lot of chemical engineers will go to work in household products or work in food manufacturing companies. P&G, actually, a large percentage of their employees are Purdue alums, which is cool. So Procter & Gamble, so that's everything from Tide to Kraft. So lots of applications for chemical engineers. Next up is civil engineering. As you might expect, it's all of the infrastructure around us, but it might be more than you think too. So it's everything we see, roads, bridges, tunnels, but also the underground infrastructure, those pipelines and water distribution systems that are underground, our electrical grids and how they're laid out. That falls underneath civil engineering. So we have several different, there's actually 9 different specialization tracks within the School of Civil Engineering here at Purdue. So there's everything from architectural engineering of designing. It's not just architecture, it's a little step beyond that of looking at entire industrial buildings. So Armstrong Hall, which is where I'm currently at, looking at its design as a whole, including all the systems within it. So HVAC systems, the electrical systems, the water systems. So it's designing a building, but not just the actual like sketching it up, but actually all the internal mechanisms that make the building work and function. Construction engineering, geomatics, structures, transportation and infrastructure, which I already kind of covered. That picture on the left is Bowen Lab. It's one of the largest civil engineering research labs in the country. That's a full-size semi-truck that's in there. You can see, kind of give you a sense of the scale of that place. That's a full-scale 3-story structure there in the back. It was actually attached to a shake table, so you can simulate earthquakes of different magnitudes on this 3-story concrete structure, see how it reacts to different levels of earthquakes, and be able to better prepare our buildings in the future as we build them, or to reinforce existing structures to better withstand earthquakes as they may come up. The picture on the right is the annual bridge competition hosted by the Purdue Civil Engineering Student Chapter. It's for high school students in Indiana and Illinois. They have to build bridges with just 20 sticks of balsa wood and a bottle of glue. And they're judged on the loading efficiency, the aesthetics, it's got to look nice, as well as the structural concepts. Did they follow actual civil engineering concepts when they're designing it? So it's a really cool opportunity for our current civil engineering students to interact with high schoolers, share with them all the things that they've been learning in class, give them some hands-on experience and what it's like to be a civil engineer. And civil engineering is going to be one of the most explosive career fields over the next several years. We need a lot more civil engineers as our infrastructure is aging and we need more of it. So it's a really great field with a lot of good potential career outcomes too. So definitely keep civil in mind if you're interested at all in building the world around us. Then there's construction engineering and management, and you might wonder how that's different from civil engineering. Well, I'm glad you asked. So construction engineering and management essentially combines civil engineering courses and concepts and foundations with management and business practices. So they take civil engineering courses, but they also take business and finance and management classes through our Krannert School of Management. So they're looking at advanced construction systems, computer integrated infrastructure, risk assessment, project management. So they actually come into play when we're actually building out these buildings and structures. So they're going to be at the construction sites, probably managing that project, overseeing its completion, making sure it's on time, on budget. If there are any issues with the actual structural integrity or bringing these blueprints to life, they can also help navigate that. They often get their professional engineering licensure so they can actually sign off on blueprint changes. So that picture on the left was one of our EPICS teams. So EPICS is a community service program at Purdue, which we'll talk a little bit about later on. So one of the teams is actually working with a village in Ecuador to design and then build a community center. So they actually designed from scratch a community center for this village. And then they worked with the local government there to sign off on the blueprints, make changes and all that, and then actually start building it. So it had classrooms, a kitchen, the first public library for the community. So a really great opportunity for our students to, design a building, but also they got to travel to Ecuador and help bring it to life. Really awesome opportunity. Then on the right, some of you that are space nerds, as I like to say, might recognize the guy on the left. That's Buzz Aldrin. Then on the right is Sadie. She was a construction engineering and management student who joined a grad level. As an undergrad student, she joined a grad level course in aeronautical and astronautical engineering that was developing a Mars mission design plan, essentially, to come up with how to build structures on the Martian surface. So as a construction engineer, she was able to use those skills to figure out how can we build structures on a completely different planet with different gravity, different terrain, different materials available. That report was eventually going to be sent to NASA, and Buzz Aldrin was the kind of the advisor for that team project. So he visited several times to help provide some insight and oversight of the project. And so a really cool, interesting aspect of what most people think of kind of terrestrial, Earth-based concepts of construction engineering, being able to apply that to extraterrestrial things for the moon and for Mars. Next up in our world tour, electrical and computer engineering. This is 2 different majors you can choose from. So it's the School of Electrical and Computer Engineering, but you can choose to major in electrical engineering or in computer engineering based on your interests. So as you might expect, this is basically anything that deals with electronics, electrical signals, electrical impulses, they're going to have a hand in it. So automation, signals and image processing, so scanners and a lot of those devices to test for electricity and those sorts of things. Power and energy systems, fields and optics, hardware and software, all of that falls underneath the umbrella of electrical and computer engineering. That photo on the left, a team of ECE students and professors are working on technology that allows for secure communications between on-body devices. Now, stay with me here. The human body carries electrical signals really well across our body. That can actually have some security issues. So if you think of like, I'm wearing a watch that's Bluetooth. Our body can actually act as a natural antenna for those Bluetooth signals, so it kind of amplifies that off of our body. So a hacker could theoretically come up and hack into your devices that you're wearing on yourself. A real, from a medical perspective, pacemakers. If you have a Bluetooth or Wi-Fi enabled pacemaker, that could be a threat. A hacker could come in and mess with your pacemaker, which is not great. So they're working on this little thing. It kind of looks like a watch, sort of, here on the left. It works with the signals that are amplified by your body, and it basically traps those signals on your body. So, whereas the signals might be like transmitted 5 to 10 meters away from your body just by natural signals, this would limit it to be just barely off the skin. It would keep all those signals on the body. And it uses 100 times less energy than traditional Bluetooth communication. And it keeps it within a centimeter off the skin. But it also allows, it's kind of like an on-body network. So it can actually transmit signals to so your watch can talk to your pacemaker directly on the body instead of having to use Bluetooth technology. So wild concept, really, really cool. Then on the right, that is the cephalopod. That is a underwater ROV developed by the Purdue student chapter of the IEEE, which is the Electrical Engineering Professional Society. Cephalopod was completely designed and built here on campus using specialized machinery, the 3D print lab, our Bechtel Innovation Design Center, Makerspace, and it can be adapted to a variety of different missions. So there's an annual competition where that has to do a specific thing. So it's modular. They can take off some components and add some others based on what the mission parameters are. So a cool little opportunity where they got to build this underwater ROV entirely on campus using things available to them here on campus, which is pretty neat. Next, environmental and ecological engineering. This is a field, it's one of our newer majors here in Purdue Engineering, and it is essentially looking at the world around us and how we can protect the world around us. So air and water quality, sustainable energy, environmental remediation. If we have negatively impacted the environment, how can we bring it back to health? Life cycle engineering. How can we get more use out of the products that we use every day instead of just throwing it to the landfill or even recycling off the bat? Is there another use we can use it for? And then public health. How can we train engineers and scientists and all of that to approach things from an environmental perspective to protect our precious natural resources around us? So on the left, one of the EEE classes that students can take involved them learning about rain gardens, which captures rainwater and can prevent runoff into overloaded streams and sewage systems during events of heavy rain. So basically redirects that into these rain gardens. And so after they were learning about these systems, they actually got to go out around the greater Lafayette, West Lafayette community and install them around campus and around the city proper. So they got to learn about it and then immediately go out and build them out and watch them in practice, which is cool. On the right, this was a research team here at Purdue that was sponsored by the National Science Foundation to study basically how we repair water pipes that have failed across the country. What we would typically do is instead of pulling out a failed pipe, digging it up and pulling it out and putting a new one, that's really expensive and costly. They would go in and lay this resin inside, kind of looks like toothpaste, and you use steam to basically cure it, and it basically creates this new pipe inside the old pipe, which is great. A lot less intrusive, a lot quicker, a lot cheaper. Well, we found that downstream from these pipes, after we've done that, we would see algal blooms in any ponds or retention ponds or lakes that they might flow into. Sometimes we've seen mass fish kills, the fish just dying en masse at the ends of these pipes. So we're starting to wonder if there might not be some bad chemicals that are coming out of this process. So this team actually developed technology that could capture the steam and when they're curing straight from the process and analyze it. And they're breaking down, they took some samples of the resin too to try to figure out what's in it and trying to look at what are the ecological ramifications of this. And they found a lot of things that were hazardous to human health, to our natural habitat's health. Some chemicals were coming out in the vapor that would come up through the manhole covers as we're doing the steam cure process. So basically helping to protect the civil engineers that are working on these projects, as well as the environment and the people and the children around these projects too, to make it safer for everyone involved. So really critical research that was a very urgent need. Next up, industrial engineering. This is a field of engineering that not a lot of people know about until they come to Purdue. But I think personally, it's one of the coolest because it's all about optimization and processes. So complex systems and networks, decision-making, next generation products and services, optimization, quality control. These are all research areas within industrial engineering. Other nicknames for them are optimization engineers, process engineers. So they can look at any sort of process. It can be how decisions are made in a company. It can be how a product is made on an assembly line. Anytime there's a flow of things, they can look at that and see how can we make it more efficient. So on the left, this is kind of using next-gen products and services in a way that we might not have initially thought of. So that is a mock surgery with a surgeon working next to Baxter. Baxter was a robot designed for factories that could work alongside humans. So most robots on assembly lines, they're programmed to do a thing. And they're going to move their arm and do the thing no matter what's going on around them. So if you get in their way, you better watch out. Baxter is different. He's designed to work alongside humans. So he's programmed to do things, but he also has cameras and sensors to know what's going on around him. So if you accidentally got in his way when he's reaching to grab something and he hits you, it's going to be with lower impact and he's going to notice that he hit you and stop. We're also taking that a step further to work in an operating room. So that they taught Baxter a series of voice and hand signals so that Baxter could know how to help the surgeon. So basically they could do a gesture or a voice command telling Baxter like, hey, I need the scalpel, and Baxter will hand the scalpel to the surgeon to use. So it can free up some of the other techs to work in other operating rooms and kind of redevelop resources, as well as making the operating room a little bit more efficient for the surgeon and for the patient. On the right, this was another student startup at Purdue. There are a lot of student startups every year. This was 2 industrial engineering students teamed up with a computer science student to create Froyo Express, Froyo on the go. The idea was it was basically like a gas pump model. So you could put this in a convenience store and you had toppings to choose from, and then you just dispense a set amount. The store could choose, you could have it to be based on how much you dispense, it'll charge you accordingly. So that's kind of like the gas pump model. Or you might just have 2 sizes of cups and they'll bill you for whatever one. So instead of having to have a giant Froyo store with a whole team of staff, it was all this automated machine. It would notify the store owner as well as the company when it's running low on materials and running low on Froyo, so it could be restocked real quick. So a lot more efficient. So student startup, they actually featured it in the basement of the Purdue Union where there's a dining court. It was also featured in one of the grocery stores over in the residential side of campus, which is cool. They received over $30,000 in their initial round of funding. So it's just another cool student startup example. So these IE students were looking at, hey, Froyo is kind of inefficient because you always have to have like a store with a whole bunch of people. And how can we get Froyo to more people more cheaply? All right, we have 3 left. Next is materials engineering. As the name suggests, it's looking at all the materials around us. So all the things and what they're made of. So metals, plastics, ceramics, nano and microelectronics, biomaterials, and then basically, processing properties and modeling of materials, basically understanding the materials around us, seeing how they work, how they react under different situations. So they are looking at, you can look at a roller coaster. What types of wood or what types of steel should we use to make sure it's durable, long-lasting, could withstand all these forces, and also work well in whatever the climate is. If it's humid southern Florida, or if it's up in Sandusky, Ohio at Cedar Point, where you have extreme heat and extreme cold. So what the things are made out of, as well as new material creation. Is there a new material we can create that's better suited for a specific purpose? So on the left, that is one of our materials engineering professors as part of an international team of researchers. They've discovered a way to make super strength aluminum. So it rivals the strength of stainless steel, but it's a lot lighter and cheaper to produce. So it could, if it works out in practice, really revolutionize the automotive and aerospace industries. It actually proved to be one of the strongest aluminum alloys ever created. So in that photo, it's a sample of the aluminum alloy. It's being prepared for analysis under an electron microscope. So that kind of goes back to the modeling and processing of materials. They can kind of grade it, and they've also got all these devices that can scan it. On the right, this is kind of a different application of materials engineering that you may not think of. A materials engineering professor is heading up a partnership between Purdue and Microsoft to advance quantum computing. So the ultimate goal is to produce a functional quantum computer, which we've really struggled with. So instead of zeros and ones, it's a lot more complex than our typical computer framework. So working with Microsoft and just a handful of other universities from around the world, they're looking at how they can use advancements in materials engineering and different materials to create a functional quantum computer. Pretty cool stuff. All right, second to last, I guess we technically have two more after this. So mechanical engineering is next up. This is kind of what most people know of and maybe think of when they think of engineering is mechanical engineering. It is basically anything in the world around us: acoustics and noise control, bioengineering, combustion, fluid mechanics and propulsion. So there's some similarities there between agricultural engineering and mechanical engineering, those machine systems and fluid mechanics. Robotics and technology, all that falls underneath mechanical engineering. So basically looking at statics and dynamics, things that don't move, making sure they don't move. Things that do move, making sure they do move like they're supposed to. So that could be the mechanics involved in a roller coaster. I like going back to theme parks. It's something a lot of people can relate to. So the propulsion systems to make it rocket off, the braking systems to get it to stop, the physics involved in making sure it gets over the hill, and making loops as fun to go on and making them more enjoyable. That picture on the left, that's out at Zucro Labs. It's the premier propulsion research lab in the world for any university in the world. We can do all sorts of incredible things out there for propulsion and propellant research. We have a multi-year, multi-million-dollar research partnership with Rolls-Royce to help them develop the next generation turbine engines. So that's a little bit of the research there on the left that's going into the turbine engines. And on the right, this was actually a Purdue student team made it to the Final Four in the bot shot competition a couple years ago. It was sponsored by Land O'Lakes in Minnesota. And this team of engineering students, they were mechanical engineering, electrical, computer engineering, computer science, and a first-year engineering student. They all teamed up to create this Boiler Bot Special. So it's play on the official mascot of Purdue, which is the Boiler Maker Special. It's a giant train on a semi-truck chassis. Google Purdue Boiler Maker Special. You won't regret it. That's our official mascot of the university. It's a giant train. So anyway, they made the Boiler Bot Special, and the goal of this competition was to create robots that can make free throws, three-pointers, trick shots autonomously. So you can actually see this animation of it in action, making trick shots, three-point shots, half-court shots. So for the actual competition that they got to go to, the final challenge was a game of horse between these Final Four robots. Sadly, our team didn't win, but they made it to the Final Four, which is pretty darn cool considering how many colleges and universities had entered the competition, and just a really cool project for them to work on. Now, our penultimate, second to last major here is nuclear engineering. Now, a lot of people immediately think of nuclear power, but it is far more than just that. There's a lot more to nuclear engineering than just power. For those that are interested in nuclear power, though, that picture on the left, we actually have a working nuclear research reactor on campus. It creates far less power than a power nuclear reactor, but we're able to use it to get hands-on experience in operating a nuclear reactor, as well as we're able to use that reactor for materials engineering research. We can irradiate materials to see how they react to being irradiated. We also were the first and only fully digital instrumentation and control system for a nuclear reactor in the United States. So we're on the cutting edge of reactor control systems, which is also really great for students that are interested in working in nuclear power plants. But again, nuclear engineering is far more than just nuclear power. They look at fuel cycle and waste management, so looking at fuel rods and spent fuel rods, how can we manage those? Hydrogen and fuel cell research, nuclear systems, reactor physics, and then also pharmaceutical and medical applications. So you think of other things that utilize radiation, X-rays. Those were helped develop in part by nuclear engineers. They developed scanning devices that can look at the world around us and make sure it's safe for us to be, looking at contaminants and toxins and natural radioactivity. The picture on the right, I don't have a photo of the actual thing, but one of the nuclear engineering professors he received funding from NASA to pursue research into a new sensor for, this is going to sound technical, but non-destructive evaluation of spacecraft structures. So basically looking at our spacecraft, and right now what we have to do is kind of a post-mortem. If a spacecraft has failed, we have to kind of bring the materials and take it apart and see what went wrong. Well, he's working on a device that can scan our space structures to look for micro stresses and fatigues and fractures that we couldn't see with the naked eye without having to rip these things apart. That costs, millions and billions of dollars. So really cool application of that. So nuclear engineering research has led to scanners for medical, scientific, environmental, and even security applications. So it's not just power. Okay. Last but certainly not least are, I guess this is technically 2 majors, so I'm still lying about how many there are. But there are 17 majors, just how many were left. So interdisciplinary engineering and multidisciplinary engineering. These are 2 separate majors housed in the School of Engineering Education. Interdisciplinary engineering is for non-traditional engineers. You need some engineering skills, but you don't plan on being a practicing engineer after you graduate. So you could do pre-medical engineering studies. So you do the pre-med track, but also take engineering courses. So really great if you want to go into prosthetics or biomedical technology or imaging devices, but also go on to med school. You can also do things like combining, art or fashion with engineering. We had a student do that a few years ago. So getting some of these core engineering skills, but you're going to do something else as a profession and not be an engineer. So that's a pretty niche group. Multidisciplinary engineering is a little different in that we combine multiple engineering disciplines into one cohesive plan of study. So there's different plans of study available, concentration areas underneath that major of multidisciplinary engineering. Unlike interdisciplinary engineering, multidisciplinary is also an accredited program. It's ABET accredited, which is the same accreditation that accredits all of our other engineering majors. So you can do things like acoustical engineering, lighting engineering, nano engineering, theatrical engineering. So those all fall underneath multidisciplinary. So for acoustical engineering, we've combined mechanical engineering for their acoustics and vibrations research with materials engineering for acoustical panels and materials that can shape sound in a room, with even a little bit of electrical and computer engineering for signals processing for the sound systems. So basically looking at a classroom or a library, a performance venue to make it as acoustically perfect as possible through the system you use, how it's set up, through the speakers you use, through the treatments, the materials that are used in the room. Really cool stuff. Theatrical engineering is also cool. They work with the theater department at Purdue and create really complex props, automated systems for theatrical and movie productions, and that sort of a thing. So that's kind of getting ahead of ourselves as far as Purdue Engineering. That was our 17 majors in a nutshell. And before you get to any of those, our students start in the first-year engineering program. Now, all freshmen coming to Purdue for engineering start in first-year engineering, FYE for short. But that doesn't mean they all get the same experience. They actually can choose one of 4 different pathways to the first-year program based on their specific interests and what they want to do. There's the most common route, which is ideas to innovation. There is the Goss Scholars route, which is essentially the honors variant of the first-year engineering program. There's the EPICS route, which is the community service project. You're going to center your first-year experience around that. And then finally, VIP, the project, which is research-based projects. So you're going to work with other students, with upperclassmen, with grad students, and with a faculty member to work on research projects, kind of focusing your first-year experience around that. Regardless of which of these 4 ways you go, you get the same outcomes, the same skill sets. You're also going to take the same types of classes. You're going to take engineering courses, calculus, science, communications, and some other electives and selectives along the way. As you look more into Purdue Engineering, we're happy to talk more about those different pathways, but just want you to know that 1, everyone starts in first-year engineering to get that opportunity to learn the basics of engineering and also really delve deeper into the 17 majors we have to decide which one is the best fit for you. About half of our students end up changing their mind about what engineering major they want compared to what they thought when they applied to Purdue. So you get a little bit more time to explore, but also getting all these core concepts that you need along the way. All right, so the last thing I want to mention about first-year engineering, and this is another common misconception, is it's not a weed-out program. We have around a 90% first-year retention rate in the College of Engineering. So it's not a weed-out program, I promise. We instead want our students to be successful. We're going to challenge you along the way because that's the best way to learn, but we're not going to make it impossible. And we're going to give you all the resources and the skills that you need to be successful. You just have to make sure you take advantage of them. So we have help labs, tutoring sessions. Just in the classes directly, we try to give you the skill sets and prepare you to think about how to solve these problems that you're going to face. So we're really trying to give you all those resources. It's just on you to take advantage of them. And as you can see, most of our students are, with 90% of them or more, still in engineering their sophomore year that started engineering as freshmen. So that's what I've got here for the overall presentation of what is engineering. I know this sounds like this is the end of the event. It's not. I actually next have a guided engineering tour that I've recorded for you. But before we move on to that, I just want to say again, the Office of Future Engineers is here to help you anytime throughout your college exploration process. So if there's anything we can do to help you learn more about Purdue Engineering, what it's like here, that's what we're here for. Ask any questions you have. Our goal is just to make it a much more informed decision for you. We're not here to convince you to come to Purdue Engineering. We want to help you learn more about us to see if we're a good fit for you or not. So with the end of this presentation, next I've got that campus tour I'm going to show you. And then after that, we're going to have a panel with our current students to talk about their experiences, what all they're doing outside of class, and even answer some of your questions. So with that, we're going to move over to our guided tour.
All right, so the first stop on our tour is one of the landmarks on Purdue's campus, the Neil Armstrong statue. Neil is, of course, a Purdue alum, probably one of our most famous alumni. He got his bachelor's in engineering from Purdue before going on to be the first man on the moon. So we have a statue here depicting him as he looked as a student at Purdue, so a little younger than you might have seen him in the photos when he became famous. So he's got his books there off to his right. And there's also an ancient relic that probably only the parents would recognize, but he's got his trusty slide rule next to him. So fun little trivia bit there. We also on the ground here have his quote, his famous quote, "One small step for a man, one giant leap for mankind." And then off over on this way, we actually have a 2-scale replica of his moon prints, the first steps that he took on the moon, including that giant leap. The Neil Armstrong statue is a popular photo spot for prospective students, for incoming freshmen, even for our graduating students. At the end of every semester, around graduation time, you'll see students lined up in their cap and gowns, waiting to get a photo with Neil to commemorate their time at Purdue. It's really fun to see all the students lining up to get their photos with him. But I'm actually gonna go over and try to follow in his footsteps and see if I can take that giant leap. It's a lot harder in Earth's gravity. So it's really fun to watch people follow in his footsteps and try to take that giant leap. So I'm gonna do that for you today. So let's go try it out. That's really hard. Didn't make it. Couldn't quite make it. All right, so I couldn't quite make it. It's really hard to do that in Earth's gravity, like I said, but always fun to try. It's fun to watch all the people come out here, follow in the footsteps, try to take that giant leap. So next we're gonna head into Armstrong Hall, which is right here behind the Neil Armstrong statue. It's home to our aeronautical engineering program, our materials engineering program, our first year engineering program, EPICS community service projects, and our dean's administrative offices are all in this building. So let's head into the atrium and check out what's going on in there. So here we are in the Armstrong Hall atrium. This is a great place to hang out and study in between classes or in the evenings. It's a pretty quiet space, especially at night. Now, right now with all of our COVID procedures in place, there's only a few chairs and tables and they're pretty well spaced out. But in the before times, and hopefully as we get to the new normal, we'll have all of our couches and tables and chairs back. So there's great places for discussion and groups or just for focusing on your own. It's just a nice little atrium. We'll also have some special events out here during the year as well. Now we also have a couple cool things hanging from the ceilings. Right over here is a full-scale replica of the Apollo 1 command module. This is what would have come back to Earth from space after a successful trip to the moon. Now, Apollo 1 is the one that caught fire on the launch pad during one of the test runs, killing all 3 astronauts on board. 2 of those 3 astronauts were actually Purdue Engineering alums, Roger Chaffee and Gus Grissom. So we have it on display here as memorial to them in recognition of their sacrifice in the early days of our astronaut program. On the other side of the sky bridge is the Dynamic Soarer. It was a prototype reusable space plane. So this is well before the days of the space shuttle. This is being developed in the late 50s and into the early 60s. And 2 of the test pilots were actually Purdue Engineering alums, including Neil Armstrong. He was slated to be one of the test pilots for this vehicle. The idea was it was going to launch at the top of a rocket, go up into space. It could deploy satellites, repair satellites, maybe even be a super high altitude observer, strap some cameras to it, and it could land back to ground as a plane would do. Now, there were a lot of issues with the project. It was in development for many years. We spent hundreds of millions of dollars on it, but we couldn't develop a rocket powerful enough to take it to space. The Air Force, which was funding the project, was struggling to find a good mission objective for it. So ultimately, the program got scrapped before even a prototype flew. Neil was very disappointed. He never got to fly it. He was very excited for that opportunity. Now, even though it never actually flew, it's had a long-lasting legacy even to this very day. It really kick-started our research into reusable space vehicles. A lot of the research that went into it went over to what eventually became the Space Shuttle project. And there's even some of our unmanned drones. We have some space vehicles that will autonomously fly into space and come back to Earth. That was also born out of this project as well. So that's about, I think it's about a 3rd scale replica of what the actual vehicle would have looked like. That's on loan to us from Boeing, who was the partner that was selected by the Air Force to develop this space vehicle. Now, just to the side of the Armstrong atrium, we have some more cool little hangout spaces outside of one of our classrooms. But we also have a piece of the moon here. This is a lunar sample brought back by Apollo 17, which interestingly was headed by Gene Cernan, who is the most recent man on the moon and a Purdue Engineering alum as well. So we have the first and most recent men on the moon from Purdue Engineering, which is pretty cool. So we actually have a piece of the moon right here. You can come up and check it out. It's really cool, on loan to us from NASA. Martha Chaffee, who is the wife of Roger Chaffee, who perished in the Apollo 1 fire, she actually coordinated with NASA to have this lunar sample be displayed here, again, kind of in his memory of what he had hoped to accomplish as one of our pioneering astronauts. We also have a wall here dedicated to Roger Chaffee and his legacy as well. So pretty cool that we have a piece of moon here on campus. Also a great opportunity to commemorate one of our pioneering astronauts for both Purdue and the country as a whole. Just down the hall here on the first floor from the atrium is one of our ethics labs. We've got the prototyping lab here, we have a computer lab, a hardware software lab just down the hall, as well as their main office. EPICS is a community service program at Purdue. It's open to all students at Purdue across all classes and grades and levels, and it's a great way to do some community service in the local or even global community, and for engineering students to get an opportunity to apply some of those engineering skills to a hands-on project. With dozens of teams to choose from and hundreds of students in the program from all across campus, you get to work with students from all across campus, not just engineers, and work on a variety of types of projects. We have a lot of teams that work with local organizations. We have some that work across the state, across the country, even some of our teams working with global partners around the world. So you have the opportunity to make a huge impact in the local community and the global community. There's all sorts of different roles within each team. You can work on client relations, working with your project partner, that external party that we're working with. You can work on the financial side of things, keeping the team on budget. You work on the actual administrative, like logistics of the timeline and keeping things on time. Or you can also work obviously on the actual build and creation and prototyping of whatever it is you're building and really flex those engineering skills. We have a few examples of some of the teams here with EPICS. We've partnered up with Habitat for Humanity to help build homes in the local area, as well as in other parts of the world. We have built assistive devices and musical instruments for children with disabilities and special needs. We helped build a child-friendly version of the Indiana Bicentennial Torch. So a few years ago, Indiana celebrated our 200th anniversary as a state. A torch was created actually by a Purdue Engineering student. And on one of our EPICS teams actually made a child-friendly version of it. So it was a little bit smaller. It was made out of plastic, so lighter weight. It had a LED flame on instead of an actual flame for obvious safety reasons. So cool little project there. But lots and lots of different types of projects. We've created children's museum exhibits, assistive devices, a lot of technological things to make things easier for schools or families or kids So potential clients will actually approach EPICS and see if our students can help them out with a need that they have. And we'll work with them to see if it's something that we can do. EPICS is a semester at a time commitment. You just sign up for the class anytime you want. And you can be in it for multiple semesters to see a project through completion, or you can do it for just one semester. You can switch teams after a semester or so if you want. So you're going to be in it as long or short as you'd like to get that really great community serve experience and help make a difference. It's, I think, one of the most impactful things you can do as a student at Purdue is getting involved in an EPICS community service project. So here we are at one of my favorite places in Armstrong Hall. We're down here in the basement. This is the prototyping studio. It's the 3D print lab available to our first year engineering students for their team projects. But also it's run by our 3D print club, which any engineering student, faculty, or staff member can be a member of. I'm actually a member of the 3D print club myself. And so there's a variety of 3D printers in here. There's typically a whole lot more than what you can see right now. But in COVID, they shut down the lab, and the lab managers actually have the printers with them, and they can still print off pieces and then leave them for members to pick up. But in a typical operation, there's a whole slew of different types of 3D printers in here with different levels of granularity and precision. So it's just a great little studio for those that want to get involved in 3D printing. You can use the space, you can become a member, you can even become one of the people that helps train other people on how to do it, checking design files and whatnot. And they'll also help you if you're not very familiar with creating those 3D designs. They'll help you walk through that process so that you can print what you're looking to print. So here we are in one of the two first-year engineering classrooms. Depending on the day of the week, you'll either be in this classroom here or one that's a little bit down the hall here in the basement of Armstrong Hall. This one is focusing a little bit more on group collaboration and discussion. So it looks sort of like a traditional classroom, but it's got a bit of a spin on it. So these numbers that you see here in front of the desk correspond to the teams. Now, as I mentioned in the presentation, the first-year engineering students are paired up into teams of 4. You work with that team of 3 other students the entire semester, and then in your second semester first-year engineering course, you'll get a new team of students to work with. So those numbers correspond to the teams that you're in. So you're going to sit with your team. It's in a 2x2 format. So you'll have you and a teammate, and then your 2 teammates behind you. And that back table is actually a little bit wider, and the chairs are on rollers. So typically we'll start off with a brief presentation from the instructor, and then the rest of the class period is going to be you interacting with your teammates. So you can turn around and start chatting with your teammates behind you. There are plug-in stations for laptops as well as Ethernet cords. If a student doesn't have a laptop, they even have laptops that they can check out to students to use during class. And so we're really going to work on collaboration, kind of research, talking things through. So we could be evaluating maybe the last exam that we had. The professors actually look at trends for each exam that students take and quizzes that students take to see, is a large portion of the class not getting a concept? If that's the case, they're going to reinforce that concept as they're also teaching new materials in the next module of the class. So really trying to make sure that everyone is keeping up and understanding what they're being taught and not letting any of the students fall behind, which is really cool. So this classroom is a little bit more traditional looking format, but still having that spin of real intense group collaboration in the course. Now we're going to go down the hall and look at the other classroom, which is a very different type of setup, and kind of talk about what that looks like. Here we are at the other of the 2 first-year engineering classrooms. This is the design studio, part of the Eye-to-Eye Learning Laboratory, Ideas to Innovation. It's also a play on words of being eye-to-eye, because that's actually how the students sit when they're in this classroom. Now it's locked up and dark because it's during the summer, there's no classes. So I'll throw up a picture on the screen so you can see what it looks like in action. But basically, there are long tables in this room, and there are high chairs on rollers with 2 students per team facing their other 2 teammates along these long tables all throughout the classroom. It's a very non-traditional setup. There is no front central focal point of the room. Instead, it's kind of a decentralized classroom. There are large screen TVs along each of the 3 walls in there that display any presentation that might be shown by the instructor. And so instead of it being a one-way lecture for this class period, instead the students watch some video lectures online before they come to class that are going to cover a lot of the concepts that they're going to work on. And then when they actually come to class in the classroom, they're going to spend the majority of that class time actually working on a project and really putting into practice what it was they were learning about in those video modules online, all with their teammates. So it's very much a very active classroom that's going to be hands-on oriented. So they might be working with MATLAB, which is some complex number crunching software used in most fields of engineering. They might be building a project, might be building a straw bridge. Who knows? But the whole point is they're actually engaged with their classmates, with the instructor, with the undergraduate teaching assistants that are walking around the room. So very active learning with those 2 first engineering classes. So that was our tour of Armstrong Hall, which you can see there off to my right. It's at the start of what we call Engineering Mall. So the Purdue Gateway here kind of starts the Engineering Mall walkway. You go down this walkway, and on the left are several engineering buildings. So I'll show you kind of where they are located, and we'll kind of go from there. So as we make our way down the Engineering Mall, you'll see Armstrong Hall there on the left. On the right is the Purdue University Student Health Center, or PUSH for short, kind of like an urgent care for Purdue students. Then there on the left is Hampton Hall of Civil Engineering, lots of classrooms, lab spaces, the administrative offices for civil engineering. As we continue further down, on the left is Forney Hall of Chemical Engineering. On the right is Schliemann Hall, which is where the Office of Admissions is located. We're to go down, take a left after Forney Hall of Chemical Engineering, and take a look back here at MSEE. That's what this building is here. It houses the administrative and advising offices for electrical and computer engineering, as well as some computer labs for students. This is the electrical and computer engineering building. It houses classrooms, labs, research facilities for students. And then finally here, this building we're walking along is the mechanical engineering building, ending at the Gateway addition here that was added on in 2011. Beautiful shot of the bell tower there on the right. Now this is the inside of the Gateway wing of mechanical engineering building. You can see up there in the corner one of the original clock faces from the original bell tower on campus. And we're going to pan across here to the Toy Museum. So the Toy Museum is really cool. It's one of the senior design classes that mechanical engineering students can choose to do. They get to play with toys, understand how they're designed, and actually design and build their own toy. So we have toys from across the years that our students have made here. It's just a really cool opportunity to release your inner child and have a tangible, thing to end with your Purdue career with. Of course, no tour is complete without a stop at the Engineering Fountain. Officially called the Purdue Water Sculpture, it's been nicknamed the Engineering Fountain over the years because of its proximity to all the engineering buildings. It's right at the end of Engineering Mall, we have our Mechanical Engineering Building, Chemical Engineering Building, so it's kind of right in the heart of the engineering area. But it's a great place to hang out in the warmer months, to hang out on the lawns, to hang out on the benches. There's also a great tradition called a fountain run, so you'll often see students and parents and kids running through the fountain. It's a great way to cool off on a hot summer day, and just one of those Purdue traditions. You got to do it at least once before you graduate. There's also all sorts of cool lawn spaces to hang out, so you can bring a blanket and relax and study or read. You can bring a frisbee and throw that around with some friends. It's just a great little space to really take in the sights and sounds of this beautiful campus. Well, that's it for our tour. There's so much more to see, but only so much time in this event. So instead, you'll just have to come visit campus for yourself sometime, maybe this fall or in the spring, and come take in the sights and sounds yourself to get a sense of what it's like on this beautiful campus. Check out our classrooms and labs and study spaces and really take it all in. But for now, we're going to hand it over to our student panel to get that inside perspective of what it's like as a Purdue engineering student.
Okay, and we're back live. Hopefully you enjoyed that video. I know that end there kind of blew through campus, but hey, we can't give away all of our secrets. Got to give you a reason to still come visit us in the fall. On the note of tours, I did see some questions about when will tours start up again. Admissions, the Office of Admissions is doing some limited campus tours this summer. They're very limited capacity. They're outdoor only, but you still get a chance to visit. However, personally, I would recommend waiting till fall. We hope to be somewhat normal by fall, or maybe even spring, especially if you're a junior or a sophomore or a freshman. You can wait till spring and we'll hopefully definitely be a lot more back to normal by then. You got plenty of time, really. For those of you that are going to be seniors this fall, obviously you're going to want to try to visit in the fall or at least early spring. So you can visit in the summer, but there's a lot of kind of downsides with that, I would say. One, we're still under several COVID restrictions. Two, most of our students are gone, so it's going to be a different feel for campus. I guess I don't really think there's a three, but that's the main reason. So I would recommend waiting until fall or spring, because it'll just be a much better visit. We'll have all of our students here, all of our offices and departments will be open, get a much more fuller experience and really maximize your time. when you're on campus. All right, so all that out of the way, let's introduce our student panelists that are here with me. We'll kind of go along the rotation here. So Nadeline, you're just to my right on screen. So let's start with you. Who are you?
Hi, my name is Nadeline Goras. I apologize for the camera quality. My computer is not doing so well. I'm a junior, now senior in biomedical engineering. I am a pre-med focus, which means I'll be hopefully going to medical school after my undergraduate. Some things I do on campus are I am outreach director for PSEF, which is the club that's talking to you right now. I also participate in undergraduate research in Boiler Gold Rush. Oh, and I'm from O'Fallon, Illinois.
Nice. Brooklyn?
Hello, everyone. My name is Brooklyn Decor. I am a junior in mechanical engineering from St. Charles, Illinois. I am involved in PSEF on campus. I also do a lot of volunteering outside of campus, which is super cool. And I think that's it. I don't know if I missed anything.
Sounds good to me. Griffin, how about you?
Hi, I'm Griffin Lahanen. I am a will-be sophomore in environmental and ecological engineering. On campus, I'm involved in PSEF, also do a number of intramural sports. I'm from Rosemont, Minnesota, and that's about all I got.
Nice. So all three of you have mentioned you're involved in PSEF. So let's start with that. What is PSEF, and is that why you're here? So Nadeline, do you want to talk about what is PSEF? What does it stand for?
Yeah. So PSEF is a group for engineering undergraduates at Purdue. And basically our main responsibilities is to kind of be a source of outreach for incoming students, help to answer any questions. In normal times, we give tours on every weekday. Unfortunately, that kind of had to stop the last couple of semesters, but we're transitioning back to that. We also have a bunch of online resources. We have a Discord channel for prospective students. We communicate a lot virtually. Yeah, that's pretty much our main responsibilities. We're also like a really tight-knit group, and we're really good friends inside the club as well.
Yeah, definitely great for social and for outreach opportunities. We really couldn't do what we do without the PSEF students helping us out for our outreach events. So being student panelists for this, giving those engineering facilities tours in the before times and the new normal when that comes. So it's a great opportunity to get involved for those that are really passionate about Purdue engineering and want to share that passion with others. So for all of you, I want to really start with the basics. So many of our viewers are probably freshmen, sophomore, maybe a few juniors, but they're still trying to figure out, where they want to apply to, let alone where they'd even want to go. So what was it about Purdue that attracted you to apply and ultimately decide to come to Purdue? Griffin, let's start with you.
Yeah, so two things that I kind of thought about when I was looking to even apply to Purdue was first thing I kind of knew and talked to my parents about was that I wanted a Big Ten school. Purdue provides that large Big Ten atmosphere in terms of athletics and in terms of the size of the student body. We do have around 37,000 undergrad students here. Yet you still get kind of the campus and small school feel in regards to the size of the campus, in my opinion. So that was one thing that kind of led me to even investigate Purdue and to start looking at it. I had never been to Indiana before I even started to be interested in Purdue. So that was something that led me to it. And then the other thing was our first year engineering program. In my high school did not have any engineering courses, anything that even led me to know what an engineer really did. So being able to come in as a first year engineer and not have to decide on that discipline right away was also something that really interested me.
Nice. Brooklyn, how about you?
So kind of similar to Griffin, I wanted a big school to go to. Purdue being a Big Ten school, it not only leads to like having so many friends on campus and so many abilities to make friends, but there's also so much to do. The football games, the basketball games, the clubs. There's like so many clubs, extracurriculars you can join here on campus. So that was like one main reason I chose Purdue, and the second was just that was a well-ranked engineering school with good tuition rates. So it was really a good financial option for my family, but it also provided me a really good engineering education that I knew I would appreciate in the long run.
Nice. Madeline?
Yeah. It's kind of interesting in the way that when I had come to visit Purdue, I actually had almost decided on another school and I didn't even really want to come. And basically the only reason I toured was because my mom wanted me to make sure I checked all my bases. And I think the main thing that attracted me to Purdue at first was the campus. It's a beautiful campus. I fell in love with it when I had my tour. And from then I only wanted to learn more. And I think the one thing that really attracts me to Purdue and is now my favorite thing about it is how collaborative we are, especially within the engineering program. I don't really feel competitive against my classmates. We're all kind of working together to achieve like our goals and our projects. And it's a really welcoming atmosphere and something I really appreciate here.
Nice. Yeah, the collaborative community is very cool, and I think sadly kind of unique, or at least not as common, especially in those top tier engineering programs. They can too often be very kind of competitive feeling, cutthroat feeling almost. Definitely not the case here. And I think that really starts with how we kind of set the tone in first year engineering. So I didn't really mention this in the slides, but in first year engineering, you're actually paired up with other students and teams. I talked about it on the tour. So you're paired up with your team of other students, and you work with them the entire semester. So we're really trying to focus on that collaborative nature right off the bat and learning how to work together to solve problems collectively. So let's talk a little bit about your first year engineering experiences. You know, what were your thoughts on it? Did it impact what major you chose? Did it like change your mind, or did it reinforce what you wanted to do? And what was that kind of those group collaborations? What were those like? So I actually saw somebody commented, "Man, I'm always the one that ends up doing all the work in group projects." So is that how it worked in first year too? So let's kind of just talk about first year and your experiences with it. So Brooklyn and Natalie, I think you did the typical first year engineering route of engineering 131 and 132. And Griffin, you did the Goss Scholars variant, which is kind of the honors program. So I'll come to you second. But Natalie and Brooklyn, we can start with you. What was your first year engineering experience like? How did those group projects go? And how did it kind of impact your major decision?
Yeah, so I actually came into Purdue knowing that I wanted to be a mechanical engineer, so I actually stuck with what I wanted to do. However, I do believe that the first year engineering program allowed me to gain a lot of good skills to have throughout my undergrad degree. For example, like Excel, coding, even teamwork. Also, I didn't come in with like a ton of like resume experience, like especially like engineering relevant projects. So all of the projects that we did are like of good nature that you can put on a resume, so it's really good for resume building. As far as teamwork goes, I don't think I really had an issue with any of my engineering teams. Even like the professors are super, like they know what your group is up to, and they'll come up to you guys and be like, oh, like if you're not putting in the effort, like you're gonna get a lower grade, and that definitely just encourages people to do their work and put their best foot forward. So I never really had an issue with collaboration on any of my teams, which was really nice.
Nice. Natalie, how about you? How was the group collaboration? Did it impact your choice of major? What was your experience like?
Yeah, so kind of similar to Brooklyn, I already kind of knew I wanted to do the biomedical engineering route. But however, I wasn't super sure in that decision. That was just kind of something I was leaning towards. So the first year engineering program was definitely very helpful in making sure that I was choosing the right thing, because they give you all these opportunities to learn about all the other kinds of engineering and everything else you can do. So it really gives you a chance to explore all your bases and make sure what you want to do is actually what you want to do. So that was nice in that regard. As far as working in teams, I was definitely like whoever said that in the comments. I was also the person who did all of the work in high school, and I'm sure that's the case for like 95% of the engineers in Purdue engineering program. The good thing about going to Purdue, especially when you're paying like a lot of money to go to Purdue, is that typically the people you work with will tend to be a little bit more motivated, because you're paying for a degree. It's hopefully what you want to do in the future. You've already made it to Purdue, so you've shown you're a hard worker. So definitely a lot better than my high school experiences, that's for sure. It was a lot more even. I will say that you can still have bad experiences, but it's not necessarily as common, and the teachers and professors will definitely give you a way to work around that.
forgot to unmute myself, sorry. There are a lot of kind of safeguards in place, but also just proactive efforts to really ensure that groups are truly helping each other out and that one person isn't taking it all. You evaluate your peers. So there's one way of saying having a kind of a check and balance. So if one person's not doing anything or is doing all the work, that's going to probably become pretty apparent. But also the instructor and the undergraduate teaching assistants are all kind of trained in conflict mediation, should that ever arise. But like there's a lot of science in how we even put our teams together. So we're going to make sure they're a very diverse team of 4 students. So typically each student will have a different interest in the engineering field. So it'd be like mechanical, aero, civil, industrial. It's not going to be like 4 mechanical engineering students. So we're going to be very diverse in that way. You're going to have different backgrounds and experiences. At least one student on the team will have computer programming experience so they can help the others, for those that have none, because we don't expect you to have any when you come to Purdue. So there's a lot of science in how we even just put our teams together, let alone how we encourage them to interact with each other. So Griffin, you did the Goss Scholars program. So as a quick primer, for those, if you apply to the Honors College at Purdue on your application, as well as to the first year engineering program at Purdue, and you're admitted to both first year engineering and to the Honors College, you're automatically a Goss Scholar, which is the honors variant of our first year engineering program. Now I'm going to make this a little more confusing, and you've got plenty of time to get some clarity on this as you move forward, but you can also join the Goss Scholars program without being in the Honors College. So let's say you don't want to do the honors program at Purdue, the overall honors program, or you weren't admitted, but you still want to do the Goss Scholars honors version of first year engineering, you could apply specifically to the Goss Scholars program later on. Don't want to muddy the waters too much, but just so you know, there's a couple ways of going through the Goss Scholars version of first year engineering. So, Griffin, what is this Goss Scholars version of first year engineering? How is it different, and what were your experiences with it?
So I am actually not an honors student. I was in EPICS my first year.
Oh, that's right. You were in EPICS.
Yes, I know some people that were in honors, so I can talk about that a little bit.
Sure. Let's go ahead. If you want to talk about Goss first, then we'll talk about EPICS. Sorry about that.
Sure. So from my basic understanding, pros of being an honor student or being in the Goss Scholars learning community is that their first year engineering class is usually a bit more physics-based. It's actually worth more credit in terms of like course that you're taking, and then you just don't take the physics course as opposed to the other engineering students. Typically, they have a semester-long project. They're working in those same 4-person teams that you do in 131 and 132. They have a semester-long project where they're working with a Raspberry Pi, which is like a sensor, and it's something that can be coded for a robot that they then use to perform various tasks, that kind of thing. If you think about like Lego First Robotics, it's similar to that. Some people may have done that in high school. But honors typically just tends to dive a little deeper into some things, and therefore they're awarded with more credit. And then later in honors, they end up having to do a dissertation of some sort and a bit of other kinds of work, including research in some regards.
Awesome. So essentially, a little bit more rigor in the curriculum for first year engineering, a little bit more depth into the field of engineering. So it's sort of a traditional honors program in that regard of adding some more rigor and depth within your intended field of study. I saw some questions about what is the Honors College. So the Honors College is the overall honors program at Purdue. It's the only way to receive an honors diploma upon graduation. You can apply to the Honors College on your Purdue application. You can also apply as a current student down the road if you wish to do so. The Honors College is separate from engineering. So the Goss Scholars program is kind of how engineering fits into the overarching Honors College. The Honors College is all about cross-disciplinary interactions and experiences. They build on kind of pillars of experiences and foundational knowledge and outcomes. So it's a very non-traditional, I would say, honors program. You have to do sort of a research scholarly project as part of the Honors College, but it's really focusing on expanding horizons through multidisciplinary efforts. The Goss Scholars program here in engineering for first year engineering is, as I mentioned, kind of the more traditional honors program in that it's that extra depth and rigor within your field of study. So that's why they play really well into each other, I think. You kind of get the best of both worlds. So you can choose to do, honors college and Goss college, or just Goss college and not do honors college. So you have that flexibility, which is nice too. Honors college itself, I feel, is not for everybody. Just by being an engineering student alone, you are already an honors college student. Our average student admitted to first year engineering program for last fall, our average ACT was a 32. Our average SAT was a 1410. Our average high school GPA unweighted was a 3.8. So you're a great student. So the honors college for an engineer is really for those that really want to go above and beyond. They don't want to settle for the norm. They don't want to settle for the typical plan of study. They want to further challenge themselves and broaden themselves. So with all that being said, don't feel obligated to pursue honors as an engineer. Employers don't really care that much. They really want to know what experiences you've had and what you bring to the table for their company. The honors college can lead to some cool experiences to talk to employers about, but you can also get really cool experiences and opportunities to talk to employers about through other means outside of the honors college. So it's great for the students it's great for that type of students that want the honors college, but it's not for everybody, and it shouldn't be an obligation. You shouldn't feel obligated to do it. I hope that makes sense. Definitely look more into the honors college at Purdue. honors.purdue.edu is their website. Ask questions, learn more, talk to students, and see if it's right for you. But again, just don't feel obligated. It's not something you have to do, or you're going to miss out on everything and won't get a job. We have a 95% placement rate for all Purdue engineering graduates, regardless if you're in the honors college or not. Okay, let's talk about the student experience, things you guys are doing outside of class. So obviously you're involved in PSEF. What are some of the other things you're involved in, or students can be involved in outside of class to kind of get that break from the stress of academics and homework and all of that? What do you like to do for fun? What are some things students can do? Brooklyn?
Yeah, I can take this one. I'm not involved in a lot of things, I guess Purdue related on campus. However, I do enjoy the basketball games and football games. I go to those almost frequently, every basketball game or football game you'll see me at. But I also like to go off campus and volunteer. I mentioned volunteering a little bit earlier. I've currently volunteered for 2 organizations. One is Natalie's Second Chance, which is a dog shelter. It's a really cool organization that I would recommend you get involved in. Basically my responsibilities are I go and walk the dogs, but I can also take one of the shelter dogs for a day and bring it to campus and kind of hang around with it, which is super cool. And then the second one that I volunteer at is Therapy and Therapeutic Writing Center, which is actually a current EPICS project that's going on right now. So it's a cool little tie there to our engineering community. But through Therapy, and it allows children with disabilities to be able to ride horses. So that's a pretty cool organization. And the EPICS project that's actually being done right now is to build a mechanical horse that they can practice riding on to get over their fears.
I've seen that in the EPICS lab. It's pretty cool to see. Natalie, how about you? What do you like to do for fun outside of class?
Yeah, like Brooklyn mentioned, I love to go to the Purdue basketball, football games. When they're good, it's even better. I would say a thing I love to do with my friends outside of campus, we go hammocking a lot. When it snows, you can go sledding on Slater Hill, which is the one giant hill that we have on campus, that's also a pretty popular activity. Yeah, that's pretty much what I like to do for fun. I'm not really involved in specific organizations, but I would say it's really important to make sure you have that work-life balance or school-life balance, because if you're just focused 100% on school, you're never going to make it through. So it's definitely important to make time for your friends and fun activities like that as well.
Absolutely. And Griffin, I know you kind of started, in the midst of all of this. So what do you do for fun? How have you kind of worked around that?
Yeah, I obviously started kind of my first semester in a COVID semester and a COVID year, and really started to kind of work around that and be able to blow off steam and relieve stress by hanging with some friends around campus, just in our dorm, as well as just honestly aimlessly walking around either campus or West Lafayette just to kind of get to know the area. Other things I did was our PSEF organization had a number of intramural teams that I enjoyed playing on. Intramurals are a fun way just to stay active if you choose not to go to the gym, which is also something that we have on campus that a lot of students take advantage of. But otherwise, yeah, just I like to walk around campus, bike around it, just kind of be active.
Nice. I saw a couple people were asking about opportunities for study abroad. I don't think any of you have studied abroad, but do you know of anyone that has? What kind of opportunities there are? Anybody want to talk about study abroad? Natalie?
Yeah, so I was actually supposed to study abroad, and then of course COVID kind of ruined that one. But I was supposed to go to Scandinavia for what's called a Maymester. So basically, what you do is after everybody gets out of school in May, you take like the last 3 weeks in May and do a study abroad. And the one I was supposed to go on was going to give me 3 credit hours for basically 3 weeks of work, which is kind of insane considering because most of the time you have to do a class for an entire semester. I can tell you about how I applied, like everything up to going on the study abroad. Basically, super easy to apply. Purdue has a study abroad website. You can filter what major you're in, what you're interested in, what languages you speak, and it can give you a whole list of programs that would be good for your fit. And then you can go from there. The application process is super easy. I think all you have to do is just plug in some basic information about yourself. Yeah, and the cost, I can't remember the exact specifics, but I remember it was a lot cheaper than if you were just to go and take a trip to Scandinavia by yourself because they do cover a lot of things for you, which was nice. Yeah, that's basically the extent of my knowledge on it. But I will say for my friends who did do study abroad, they'll say it was like the best experience they had in college. So a little bit jealous, but it's fine. But yeah, definitely a really rewarding experience. And if you get the chance to do it, highly recommend it.
Yeah, there are a lot of opportunities for study abroad for our engineering students. It's something that the College of Engineering is very passionate about, expanding access to study abroad opportunities for our students without adding time to graduate, time to degree, technically. Just for engineering specific study abroad projects, there's over a dozen countries to choose from, I think a couple dozen. And looking at all study abroad opportunities at Purdue, there's dozens of countries. There are over 200 study abroad programs to choose from. There are a lot of scholarship opportunities out there to, typically at least cover travel costs. Many of the programs will just pay Purdue tuition. So if you get scholarships or financial aid, it will count towards that, which is cool. And then local room and board, which can be cheaper than Purdue. So you might actually be a lower cost, as Natalie said, than if you were here on campus studying abroad, which is cool. Lots of opportunities for study abroad. We really want our students to pursue that are interested in it. We want more students to be interested in it too. We've more than doubled the number of engineering students that will study abroad before they graduate over the last 5-10 years. So really awesome opportunities for that. I've talked to several students that was another one of the factors for why they chose Purdue. Other places we're looking at had pretty limited options. We have so many options for study abroad, which is very cool. So we're kind of coming up near the end of our time. There's a lot of questions come in, but I wanted to make sure, since this is like the introduction of Purdue Engineering, just want to at least kind of cover the basics. So we haven't really covered internships and co-ops yet. I think that's going to be kind of the last thing we touch on before we wrap up tonight. And then I'll let all our viewers know how you can follow up with us for more questions down the road. This is just the start of your pathway, your journey. So let's talk a little about internships and co-ops. I think all three of you have had internships or are currently on one. So let's talk a little bit about the process of how you got it, as well as start off maybe with like what experience you've had or will have, and then let's talk about kind of how you got them. So Griffin, how about you? Let's start with you.
Yeah, so I just came out of my freshman year and was already lucky enough to have an internship this summer here in Wisconsin. I'm an environmental engineer, so I'm working at a recycled paper mill here in Wisconsin, where I'm getting to use some of the skills that I learned in first year engineering already throughout the entire summer on this project that I'm working on. Basically, I was able to secure it by using the Office of Professional Practice and a number of my peers here at Purdue to, one, make my resume better, because quite honestly, before coming to Purdue, it had very little on it. It didn't look too great, and I was able to make it look a lot better. And then was also able to use my first year engineering experience on that resume and talked about it in an interview, which ultimately led to me getting this job, which was great. Otherwise, there's no shame, especially in this first experience in getting an internship and using connections. I was fortunate enough to be able to use kind of the Purdue name and to be able to milk that along with the connection to work into this internship here.
Nice. Brooklyn, how about you?
Yeah, so currently I'm in my second internship. I'll talk about my internship last year first. So I also got an internship right after freshman year. I worked at an automation company where we made automated assembly lines for companies to assemble their products. It was super cool. I got hands-on design experience. I had SolidWorks experience coming in, which helped me a lot in that internship, and I really enjoyed it. This year, I'm at Borg Warner, where we manufacture transmissions, motors, and alternators. Right now, I'm kind of in the prototype section for our motors. It's super cool. I'm getting a lot of hands-on experience assembling our electric motors since we are pretty new to that field as a company. And I also got that internship from IR, Industrial Roundtable, which is one of our biggest career one of our biggest career fairs at Purdue. It's a super easy process to go to IR. You basically just walk up to a company's booth when it is in person. This year it was online, but I had a really easy time getting that internship through IR.
Nice. And then Madeline, how about you?
Yeah, I actually don't have any internship experience just because I'm a pre-med student and that's not really what I've been focusing on, but I can talk about research if that's okay.
Yeah, absolutely. Please do.
Yeah, so because I'm pre-med, an internship can definitely be beneficial, but I chose to focus more on doing research here at Purdue. So I can talk a little bit about how I get involved. So right now I am working in a cardiovascular lab at Purdue. It's led by a biomedical engineering professor who's actually taught me in class. And it was actually very, very easy to get involved with research. Basically, Purdue has every single research lab all on one website. You can go on the website, figure out which labs you seem interested in, figure out what you like. And then basically all I did was reach out to the head professor in charge of the lab. And I believe within 30 minutes, he had emailed me back to set up a meeting. And by the next week, I was working in the lab. Typically, you can do it for credit or for pay. I do it for credit. So I take 1 credit hour a semester for working in the lab. And it actually will kind of satisfy some of my tech elective requirements, meaning I don't have to take like 1 class in BME, which is nice. Yeah, and so very easy to get involved. 1 credit hour typically translates to 5 hours of work a week, but typically they're super flexible with you. If you have a bunch of exams 1 week, they'll let you make up your work the next week, things like that. Currently in my lab, we work on cardiovascular things, obviously. I work specifically with abdominal aortic aneurysms, and so what we'll do is we induce these aneurysms in a mice model, actually, which is really cool. And so my job is to take ultrasound images of these mice as their aneurysms grow, and then analyze those images using a software and kind of make models of the aorta and the aneurysm as it grows from week to week, which is really cool to see. You get to see like how it grows bigger and bigger from week to week, which is very cool stuff. And I'm actually set to be published in a paper, which is very exciting. Definitely a big resume builder, especially if you're trying to go into anything research or medical related. So definitely a really rewarding opportunity if you get the chance.
Definitely. Awesome. So I think we've covered a lot. We've covered a lot of the basics, the different majors, what is engineering, some of the student life opportunities for our engineering students, a little overview of internships, research, study abroad. We didn't really talk about co-ops. Co-ops, the way they're different from internships is that you work multiple work sessions with a single company. So we're different than most other co-op programs out there. We actually have our students stay with the same company for multiple work experiences over the course of their time as a student. So anywhere from 3 to 5 work sessions with a company. You'll usually rotate semesters, so 1 semester on campus, next semester off campus working full-time for your employer, not paying tuition, which is great. You're instead getting paid a ton for your co-op. And so you alternate each semester. So co-op is really great for those that are pretty soon about what industry they want to work in, especially what employer they might want to work in after they graduate. Because you're still going to get a wide breadth and depth of experiences within that industry and in different aspects of it. much more depth than you can get through some internships. But internships are really great for those that want to kind of test the waters, different companies, different industries, and kind of see which one is the best fit for what they want to do after they graduate. So great opportunities for internships and for co-ops. All internships and co-ops for the field of engineering pay. So another one of the great perks of being an engineering student is not only do you get great experiences, you get really good pay. Most internships and co-ops will typically start around $20 an hour or more, depending on the employer, the industry, and it usually goes up as you advance through the years. So it's another really great way to help pay for college, or at least reduce the out-of-pocket or loan expenses. There is so much more that we can cover, but I want to be mindful of everyone's time. I wanted this session to only be about an hour and a half. Again, it's supposed to be just kind of introductory, kind of get your feet wet, get you a little exposure to the different elements of Purdue engineering and the opportunities to start that conversation down the road, so you can reach out to us over the coming weeks and months, years, if you're a freshman or sophomore, to kind of learn more about these in more depth. But at least you can kind of see what all the opportunities are and kind of get a sense of what you might be interested in. So I hope that we met that goal for you, to give you that introduction of Purdue engineering and our opportunities. I will say there are lots of ways to reach out to us in the future, and answer those follow-up questions that you have, those things that we couldn't get to today with the limited time that we had. So I'm going to throw up here on the screen the different ways you can reach out to us. But first, before I do that, I just want to thank my student panelists for taking some time out of your night, especially as you're at home or at internships. I know you've probably had long days. So really appreciate you taking some time tonight to share your experiences with our viewers, kind of walk them through the opportunities. So thank you all. I appreciate your time. And you guys have a good rest of your night, and I'll see you on campus later this fall. For our viewers, just want to say again, thanks again so much for tuning in. Really appreciate you joining us tonight. I hope we gave you a good overview on the opportunities that Purdue Engineering offers you. So I'm throwing here on the screen ways to get in touch with us down the road. So as I've been saying throughout, the Office of Future Engineers is here to help any way we can throughout your entire college search process, all the way from freshman year until all the way through you've been offered admission to Purdue. Hopefully, if you end up applying, we can help you through any part of that process. So you can call us. We're open during business hours, so 9 a.m. to 5 p.m. Eastern time. Purdue is on Eastern time. If you're calling outside those, feel free to still call. You can leave a voicemail. We'll go back to you. Best way to reach us, though, is probably by email, future-engineers@purdue.edu. You can also reach out directly to the students in PSEF, that engineering outreach organization that our three panelists were with. Their website, you can just Google Purdue PSEF, PSEF, or go to engineering.purdue.edu/PSEF. That's PSEF. You can view the member bios. They have a contact form. You can reach out to students to connect with them one-on-one, learn more about it. Our office, the Office of Future Engineers, we have several current engineering students that work on our office as well. So almost any time you call or email our office, it's almost always going to be a current student as well. We really want to put them on the front lines because they're the ones experiencing it now and going through it now. So who best to talk about our programs? The ones that are currently living it. That's all. I could talk about Purdue and Purdue Engineering all day, every day, but we all have other things to do. So thanks again for joining us tonight. Really appreciate it. Hope you all have a great rest of your night. As we say here at Purdue, boiler up, stay healthy, stay safe, and we hope to see you on campus sometime in the near future. Thanks, and stay in touch.